Implicit differentiation. What is implicit differentiation? Well, implicit differentiation is just the process of finding the derivative of a function by differentiating each term separately. Basically, it's a special version of the chain rule. Implicit differentiation expresses the dependent variable, y, as a symbol of y prime, or dy over dx. Then, you solve to find the derivative by moving dy over dx to one side. So, some prior knowledge you'll need to do implicit differentiation. Well, you need to know how to find the first derivative, and possibly even the second derivative of a function. You'll need to know chain rule, and also the hook-on factor. You need to know algebra, and you need to know how to distribute. So when to use implicit differentiation? Well, an explicit equation expresses y in terms of x. So for example, y equals x squared. In this case, to find the derivative, you just need to derive x, which basically makes it just y prime is equal to 2x. Now, however, in an implicit equation, it's different because the relationship between x and y is only implied. So the example is y squared plus x squared equals to 1, or y cubed equals xy plus 1. In cases like these, you would need to use implicit differentiation and not the chain rule. So, some careless mistakes you would make while doing implicit differentiation. Well, when you're doing this, make sure that you apply the product rule and the quotient rule when it's needed. So in cases like when the equation has x times y or x over y, then basically in these cases, make sure to do these. And when you're applying the chain rule, make sure to add on the hook-on factor, or else it'll screw up your whole equation. So some procedures you need to follow. So the first step would be to take the derivative of each variable in the function using the chain rule. Simplify the equation as much as possible. Then you move the terms with dy over dx all to one side of the equation. And then you factor out that dy over dx and divide the remainder out to the other side. Once dy over dx is isolated, you have the derivative. So the first example, y squared equals 3 plus 4x. Now, you would derive the function at first. So, y squared equals 3 plus 4x will become dy over dx times 2y is equal to 0 plus dx over dx times 4, which is the derivative of 4x. Now you simplify that equation and you end up with 2y times dy over dx, which is like y prime, is equal to 4. You isolate dy over dx, and you basically get dy over dx is equal to 2 over y. Well, that was pretty simple. So let's try a harder problem. So now we're going to find the second derivative of 4x squared plus y cubed equals to 14. First, we're going to start by finding the first derivative. So 4x squared plus y cubed is equal to 14. This equation, we need to use the chain rule first, and so the derivative of 4x squared is equal to dx over dx times 8x plus the derivative of y cubed dy over dx times 3y squared, and it's equal to 14, equal to 0 since the derivative of 14 is 0. Now, we move over the 8x to one side after dx over dx is cancelled out, and you get negative 8x on the other side. And you divide 3y squared over to the other side to isolate the dy over dx. You end up with negative x over 3y squared. Now you have the first derivative, we're going to move on to the second derivative. So, continuing on the equation, dy over dx equals negative 8x over 3y squared. Now we find the second derivative using the quotient rule now. Don't forget to use quotient rule. So, now we would basically use the formula for the quotient rule, and you find the derivative of the top multiplied by the bottom minus the derivative of the bottom multiplied by the top over the bottom squared. Once it's simplified, you get negative 24y squared minus 48xy multiplied by dy over dx all over 9y to the fourth. Now you make sure to substitute dy over dx back into the equation. So in this case, dy over dx is again negative 8x over 3y squared. And when you substitute in and simplify, you get the equation negative 128x squared over 9y to the fifth minus 8 over 3y squared. Now that you learn how to do implicit differentiation, you'll probably ace the next test. Thank you for watching.